This is Math Studies section 5.3, and on this lesson we're going to be introducing the three main functions that you learn in any standard algebra class: the linear function, the exponential function, and the quadratic function. So hopefully you've already experienced all three of these in algebra or algebra 2. A linear function is a line. And so if I draw my axes, linear function is just a line. The general format for a linear function is y equals mx plus b. The domain and range of the parent function y equals x is negative infinity to infinity. Now that can change if I translate the function, and we'll talk about that more on section 5 of the packet. The standard shape of the exponential function is a curve that slowly approaches the x-axis on one end and shoots off to infinity on the other end. The general form for an exponential equation is y equals a times b to the power of x. The domain of the parent function, and I'm going to use y equals 2 to the x is my parent function, is negative infinity to infinity, because we can see that it keeps going forever and forever in both the negative and positive horizontal directions. The range of the parent function is 0 to infinity. So we can see that it never goes below the x-axis, so 0 is the lower boundary, but it does keep going up forever, so infinity is the upper boundary. Finally, the quadratic function, the parent function, the shape of the graph is, that was really bad, the parabola, the U shape. The general format for one of those is ax squared plus bx plus c. And the parent function is generally y equals x squared. The domain of that graph would be negative infinity to infinity. Again, it keeps going forever, horizontally, both positive and negative. The range is just like the exponential function. It doesn't go below the x-axis, and it keeps going up forever. Again, those values can change if we translate the functions, because I can take a parabola and I can, slide it a couple units up or a couple units down. I can reflect it, but the basic functions would be those. So we can use then function notation with these three different functions, and we can evaluate and solve with those. So in the first example then, I have three different functions. I have a linear function, an exponential function, and a quadratic function. And to evaluate those, we just put the number where the x is and get the answer. So this first box here would be 2 times 0 minus 7. And you don't need to write the work for all of these, but I at least want to draw out the first two so you kind of get the idea of what I mean. You just keep putting the number where the x is and get the answer. So 2 times 0 minus 7 is negative 7. 2 times 4 minus 7 is 1. 2 times negative 2 minus 7. 2 times 7 minus 7. If you know how to use and have a graphing calculator, you can also put these values in the tables and get your answers. But without one, this is the fastest way to do it. So then this is the same. You just keep putting the value where the x is. So this is 2 to the power of 0 minus 3, and 2 to the power of 2 minus 3, all the way down the list. 5, 3, 6, 8, 7, 0, 9, 0, 9. So 536,870,909. So when there's two x's in your function, you have to put the number in for both of them. So this one would be 8, 0 squared minus 6 times 0 minus 2. The next would be 8 times 3 squared minus 6 times 3 minus 2. I'm going to caution you to be careful on the quadratics, especially with negatives. If you do 8 times negative 3 squared minus 6 times negative 3 minus 2, on most standard issue calculators, it will give you the wrong answer. It'll say negative 56, because when you square a negative, the calculator interprets it wrong. So just be really careful on those. That's why I always recommend using the parentheses instead of just using times. For the very, very last one, now this is solving, so you'd put 33 and solve. If you've taken an algebra class before, you should know how to do that. The quadratic formula is the easiest way. The x equals negative b plus or minus the square root b squared minus 4ac all over 2a. If you remember that. If you don't remember that, I want you to stick with the guess and check style. Try different values for x until the answer comes out as 33. And we will talk more about how to solve quadratic equations in a later chapter. So just looking at this, I can see that 3 gave me 52, so 3 was too high. So I'm going to try 2. 2 gave me 18, so 2 was too low. 2.5 works. So I know 2.5 is the answer. Okay, I'm going to try to pick up the pace a little bit on these. The next one is example B, says that we're going to rent a tennis court, and here's the formula that shows, based on how many hours we rent it, what the cost will be. Find the cost for renting for 4 hours. So this is a valuable piece of information. X is the number of hours. So if X is the number of hours, and then I substitute 4 into my equation, and 4 will go in for the x. So this will be 5 times 4 plus 8. It'll cost $28. Here it tells me the cost. I know that's y, so this has to go in for y, and then I would solve. So 4550 equals 5x plus 8. And solve it, subtract 8 from both sides, divide by 5 on both sides. And I got 7.5. So basically if I had the court for 7.5 hours, it would cost $45.50. Letter C says a population of rabbits is given by this equation. X represents the number of weeks and Y represents the total population. Find the population after 15 weeks. We're going to put 15 in for X. And just type it out, get the answer. 137.95. So, or we could say about 138 rabbits. The next is substituting 500 in for Y. Oops. So that's supposed to be 1.07 parentheses x, and I'm gonna stress the guess and check method again. So 50, 1.07, try different values for x until 500 comes out at the answer. I can see 15 was about 140, so maybe I'll try 30. And that's still too low. 30 gave me 380. So how about 50? 50 was way too high. 45, too high. 40, getting better. 35. 35 gave me 533. 34 looks like the winner. If I put 34 in for X, it gives me 498.9. And that's as close as I'm going to get. Okay, so good luck with the exercises, and ask me if you have any questions.